For this last section of videos related to lake management and water pollution, we should look to the concept of thermal stratification. This happens in lake systems, and it varies all around the world depending upon the temperature as well as the trophic state of the lake. So lakes in certain parts of the world will stratify, and even in like tropical regions, sometimes lakes will still stratify. So when lakes stratify, meaning they kind of have these three distinct layers in some cases, you'll have a top layer, or the outer layer, what's on or among, what's on the outside, the epilimnion. We'll have the metalimnion, also known as the thermocline, and then we'll also have the deepest water that's called the hypolimnion. Hypo meaning below limnion. So you can think of like hypothermia, below temperature. So hypolimnion is talking about the bottom layer of water. So those three areas. The thermocline, or the metalimnion, is characterized by this cline. Like there's an instrument called a clinometer that measures like the angle or the slope of like land. Cline is referring to like that change. Thermo refers to temperature. So it's this zone of a lot of temperature change. So we have kind of a stable temperature profile here, stable temperature profile there, and then this zone of rapid change. Now notice down here that the bottom layer is approaching 4 degrees Celsius. This is the heaviest or the most dense water will be, is at 4 degrees C. So thermal stratification, it's talking about the properties of water that make water either sink or water float based upon the temperature. So at 4 degrees C or 39 degrees Fahrenheit, water will sink. Now, when water does this, and we can think about, changing of the year in the temperate regions of the world, changing the seasons, you could theoretically get a situation where it just keeps getting colder and colder from the top to the point that all the 4 degrees C water keeps sinking, so eventually the whole lake system is all 4 degrees C or 39 degrees Fahrenheit. And at that point, these different layers of the water can mix, and nutrients can be resuspended during this time. And this allows that phosphorus or nitrogen that may be trapped, usually phosphorus is what we're thinking of, can be trapped in those sediments or those bottom layers, and that can fuel algae blooms, especially in this part of the world. In the springtime, it brings the nutrients up, and if there's enough sunlight and the sunlight can penetrate the water, we can have spring water quality problems. During these turnover events, when they happen, if you're drawing water in from one of these regions, and usually we don't draw water in from the epilimnion. We don't draw water in from up there because it's going to have more algae and more stuff in it, and it's just going to clog up our intakes. Our screens will have algae growing on them. So the epilimnion is not often used. Typically they'll want to draw the water from where there's not sunshine penetrating, but you also don't want to get too close to the bottom of the lake, because as you start near the bottom of the lake, you'll start getting more sediments and higher concentrations of all kinds of other organic matter down there. So when this turnover happens, those things that are on the bottom can get suspended into the system. So water plant managers may have to deal with this. And the more eutrophic a lake is, the more problems you're going to have with a lot of stuff being resuspended during turnover events, if you have turnover events. So there are different ways that these turnover events can happen, and you may be familiar with that term, turnover. The oligotrophic systems have their own kind of way of doing it. Mesotrophic systems are a little bit different. And eutrophic systems are a lot different. So we're going to talk about the eutrophic system here mainly. In a eutrophic system, we see the temperature in the springtime being all about the same temperature. we see the dissolved oxygen concentration in the spring being all relatively high. Okay, so cold temperature on the bottom, DO concentration pretty high. It's cold water, holds more oxygen. So the DO, 12 milligrams per liter, temperature, it's down here near 8 degrees C, maybe 45 Fahrenheit or so. Then, as you go into the summertime, in the summertime what happens is you get these three zones. We have our epilimnion, our thermocline, and our hypolimnion. You also see dissolved oxygen up here where the sun shines, where you have photosynthesis going on, less photosynthesis, no photosynthesis. At the bottom, it's so turbid, you can't get sunlight to penetrate through this layer. There's no photosynthesis down there. The stuff that's down there is consuming all the oxygen. So in eutrophic lakes, once you get down below the photic zone, below the area that the light can penetrate, there's no oxygen left. So there's no fish down here. So that is unique. The lake will smell bad if you get sediments or release water from the dam from these levels. There's no oxygen, so lots of hydrogen sulfide gas. But then as the water starts to get cooler in the fall, the water starts getting cooler in the fall, it gets cool from the top down, the heavier water sinks. You get this event where you get the mixing and everything, and you have the fall turnover. And then in the winter, you'll get winter stratification as well. And this is the diagram there for it. But summer stratification makes eutrophic lakes really easy to distinguish from oligotrophic lakes. And in an oligotrophic lake, the temperature profile still looks similar, but there's not so much sunlight going on up there, or sunlight's not being blocked or obstructed up here. It can penetrate down deep into the water. You can have photosynthesis way into the water, and then the water's cool enough and there's not such a high BOD in the bottom that you can have high dissolved oxygen concentrations even down into the cooler water. Alright, so that is a little bit about thermal stratification. Now, in this part of the United States, our lakes will turn over 2 times. There are certain types of lakes that are out there that change or turn over more often. Well, not more often than twice, but less often. These lakes that turn over less often, maybe once every 50 years or 100 years, if that turnover happens, it can release these toxic, nasty gases. So we're going to talk about those. I'm going to show you maybe an article on Lake Neos or a video. These are sometimes called killer lakes. When they turn over, they release so much in terms of toxic gases that they can be fatal. Now, with respect to thermal stratification is something that's helpful for us to think about when we're determining where to draw our water from. And in eutrophic and mesotrophic lakes, you want to draw the water deep enough from the surface where it's free of plant life and there's less clogging of the screens by algae and even mussels. And you also want to be down there because you'll get less disinfection byproducts when you treat it. But if you go too deep to the very bottom, you're going to get chemicals sucked in that will form disinfection byproducts when they interact with chlorine. So the best spot to draw your water is typically the upper reaches of the hypolimnion, is where the water intake might be if you have to draw from a lake. If you have groundwater fed sources, which we'll talk more later, those tend to be easier to treat and have better tasting water. So that's all on thermal stratification. So learn about Lake Neos. Be familiar with what unique property it is about water that makes it sink. Did you know that if water did not have the most density at 4 degrees C, lakes would freeze from the bottom up, which would be detrimental to life. Fish would not be here in the temperate area of the world. The fact that lakes have heavy water sink to the bottom, and then after 4 degrees C, the water that's 3 degrees or 2 degrees, 1 degree, and then 0, ice, floats. That is a remarkable property of water that we are very blessed to be able to have. Otherwise, aquatic systems would be devoid of life if they end up freezing over, because they would freeze from the top down. There'd be nowhere for things to go. So it's really, really nice that ice forms, and it forms and floats because water is most dense at 4 degrees C. All right, we're going to do some review, and this will conclude this section of the materials.